Hey everyone, this is Bhargav Suthar, and today we are continuing with propositional logic. Now, see, in this today's session, we will discuss what is an argument and some of the examples based on that. So, first of all, what is arguments? So, an argument, it is an assertion that a given set of propositions, that is P1, P2 up to Pn, and called premises. So they are called premises, yields another proposition, let us say capital Q, and it is called the conclusion. Such an argument, it is denoted by this P1, P2 up to Pn, this rotated T symbol, and then Q. So that means this P1, P2 up to Pn, they are premises, and it yields another proposition, that is Q, and this given symbol. Okay, so after combining all this, it gives some Q. Now note, an argument, this P1, P2 up to Pn, Q, is said to be valid if this Q is true. So that means the conclusion part is true whenever all the premises, this P1, P2 up to Pn, are true. Again, this Q is true if and only if all the premises, that means P1, P2 up to Pn, all are true. And we will use it, so this is very important. Now, an argument which is not valid, it is called a fallacy. Now, theorem, the argument, this P1, P2 up to Pn, Q, is said to be valid if and only if the proposition, this P1 and P2 and up to Pn. So what we are doing, just put and in between all these premises, that means P1, P2 up to Pn, so end, in between end, and implies this Q. Again, this P1, P2 up to Pn, so we have just put end in between all this, and that whole bracket implies the conclusion is a tautology. So if this is a tautology, then this it is true. Okay, and this is also important. Let us discuss examples based on that. The question is, check the validity of this P implies Q, comma, not P, that symbol, and not Q. See, before this rotated T symbol, whatever the statements are there, they are premises, and after that, this not Q, it is the conclusion part. Okay, so here, how many premises are there? So there are two premises. So P1, capital P1 equals to P implies Q, and capital P2, the second premise, that is not P. So they both are premises, and what is the conclusion part? That is Q, not Q. Now to check the validity, we need to check. We have just used that theorem that P implies Q and not P, and whole bracket implies not Q. It is a tautology. So if it is a tautology, then it is valid, otherwise it is not. So we will construct a truth table. So in truth table, there will be P, there will be Q, then there will be not P, then not Q, then P implies Q, then P implies Q and this not P, and the final statement, that is this. Okay, so here we have two statements. So we will have four possibilities. Either both are true, both are false, one is true, another one is false, and first one is false, another one is true. Okay, so that means CT, TF, FT, and FF. Now for the calculation of not P, TT, FF is there, so not P will be FFTT. Okay, then not Q. Now what will be not Q? So TF, TF, so not Q will be FT, FT. Now P implies Q. P implies Q, it will be TF, TT. Then next, P implies Q and not P. So P implies Q and not P. So that means it will be FFTT. And in last column, it will be TTFT. Now you can see that TTFT, all the entries, see, for tautology, all the entries has to be true. So then we can say that it is a tautology. But here in this third column, in this third entry, we have F. So it is not a tautology. So here entries in the last column are not true. All the entries are not true. So it is not valid, hence it is a false. Okay. Let us discuss second example. Determine the validity of the following argument. See, the argument is given. If 7 is less than 4, then 7 is not a prime number, then 7 is not less than 4, and this line, you can see this line, 7 is prime number. So see, here in this example we have given the argument in the words form. So first what we will do was first we will convert it into symbolic forms and then we will proceed. Now see, before this line, whatever the statements are there, they are premises, and after this line it is argument. Okay, so if 7 is so the solution will be, if 7 is less than 4, so let P be 7 is less than 4. Then second statement, we have given 7 is not a prime number, but for not we will just convert it into positive manner. So let Q, 7 is a prime number, so P and Q are there. Now 7 is not less than 4, so that comes from this P. So what will be the premises? Okay, so the argument is of the form, if 7 is less than 4, if 7 is less than 4, now 7 is less than 4, that means P, then 7 is not a prime number, so that means Q, that means not Q. Okay, so P implies not Q, so that is the first premise. Then 7 is not less than 4, so that means not P, so it is the second premise, and this symbol, and the conclusion is 7 is prime number, and that is P. So P implies Q, sorry, P implies not Q, not P, and Q. So this is the symbolic form. Now see, P implies not Q, not P, and Q. So this is the symbolic form. Now in this example we are not using that theorem, we are using some different thing. So first we'll construct this P, then Q, then not Q, then not P, and then P implies not Q. So this will be the truth table. So this many columns will be there. So we have two statements. So there will be how many possibilities? There will be 4 possibilities. So it will be TT, TF, FT, and FF. Okay. Now not Q. Q is TF, TF. So not Q will be FT, FT. Now not P. TT, FF. So not P will be FFTT. Now P implies not Q. Now what is P implies not Q? And it will be like this, FTTT. Okay. Now just check this column, the premises and the conclusion part. So not P, that is a premise. Now P implies Q, that is also a premise. Okay. Now see, in the premises form, this not P is true. Okay. Then this row, that is also true. But the conclusion part is also true. So that is correct. Okay. So this is by definition how to use it, that the conclusion part is true whenever all the premises are true. So here it holds. Now in second, in which row both the entries are true? So that means in the fourth row. So T, then T, both the premises are true. Okay, but corresponding to the conclusion, is it true? No, but it is the false one. So that is not correct. So here in the fourth line, this not P and P implies not Q, they are true, but corresponding the conclusion, Q is false, so it is not valid. So it is not valid, so hence it is false. Thank you.